Hey guys, good afternoon. We're going to go ahead and start our Monday material. We're going to be talking about Polygon angle sum theorem, and then you guys are going to be doing some practice for me when I come back tomorrow. Looking at the rest of this week, you'll notice that this unit is very quick, very short. Your dictionary is due tomorrow. You got those terms last Friday on the day of the test. We also have a very quick quiz over polygon sum and properties. So if you're paying attention today and tomorrow, that quiz is going to look really good. We're going to review on Wednesday, Thursday, and then we have a test on Friday. Notice that is the end of our 6 weeks. Okay? From the sub, you should have received a chart-like worksheet that is a front and back. If you need to pause the video so the sub can pass that out at this time, go ahead and do that. Here we go. This is the front side of that paper. You'll notice it starts off with the triangle, so make sure you're on the right side with me. And here's what we're going to be talking about today. We're going to be identifying or naming each polygon, or classifying, that's a word that we're going to use from now on, talking about its number of sides, the number of triangles formed. Okay, that's going to be a unique column. The sum of the interior angles, key word here, regular polygon. Okay, from your dictionary, if you've gotten a head start, you know exactly what regular means. If not, get it done. It's due tomorrow. You'll notice regular also pops up in the last column talking about exterior angles. So what are we doing? We're exploring the different types of polygons. We want to see if we can come up with their interior sum, their exterior sum, as well as talking about when they're regular, what happens to those interior and exterior angles. The first row, I think the first row is a piece of cake for you guys. Name that polygon. Number of sides. Now, number of triangles formed. It is a triangle itself, so it is one triangle. Okay? You'll see how that develops as we move down the chart. Sum of the interior angles. If you're not writing 180, I'm not quite sure what you're writing. Here we go. If it's regular, that means two key things, and if you need to add this to your dictionary, please do so. Regular means equilateral and equiangular. So the two E's make a regular polygon. Well, if that's an equiangular polygon, 180 divided by 3 gives us every angle is 60 degrees. Now, the last two columns. The sum of the exterior, we're not quite sure yet. But if we know one interior, can we figure out one exterior? Think about that relationship. And I'm going to draw a little picture down here at the bottom. If I have a triangle and I extend one side, this interior angle and this exterior angle share a unique relationship that we've talked about before. They are a linear pair. We can also say that they are supplementary, so the sum of this value and the sum of this value should be 180. If that relationship holds true, we know that one exterior angle will be 120. For a triangle, we have 3 of those exterior angles, 120, 120, 120, and that gives us a total exterior of 360. Next up, I know that we want to say square, we may even want to say rectangle there, but go even more broad. Generalize it, and let's say anything with 4 sides, a quadrilateral. Now, number of triangles formed. I want you to pick a vertex, any vertex. I'm going to pick vertex A. And I'm going to draw as many diagonals as I can from that vertex. In the quadrilateral, I can only draw one diagonal, creating 1, 2 triangles. If every triangle has a sum of 180, 2 times 180 gives me 360. My interior sum for a quadrilateral, anything that has 4 sides, is 360. If that quadrilateral is regular, meaning all the angles are equal, can we say 360 divided by 4, which gives us 90 degrees, every angle of that regular quadrilateral would be 90 degrees. Well, let's think about this down here as well. If I have a regular quadrilateral or square and I extend each side, that creates 4 exterior angles. Think about what you know about each one of those exterior angles. If the interior is 90, what does that make your exterior angle? Also 90. They are a linear pair. They are supplementary. They must add up to 180. So if that's 90, I have another 90 relationship, another 90 relationship, and another 90. 4 90-degree angles on the outside gives me 90 degrees for each exterior angle, and 90 times 4 giving me an exterior sum of 360 again. That's something. Let's add one more side. 5 sides, you know what that is. Go ahead and jot that down. Pentagon. Now back to the triangles formed. Pick a vertex. I'm just going to pick A. How many diagonals can you draw from that vertex? A to C is a diagonal. A to D, also a diagonal. I cannot construct any more diagonals, so think about how many triangles you've created. 1, 2, 3. Go ahead and write a 3 in that column. If you have 3 triangles inside that pentagon, every triangle has a sum of 180. That gives us an interior sum of 540. Now let's think about this. For a regular pentagon where each angle is congruent, 5 angles totaling 540. Let's divide there, and what do we get? 108. All right, let's think about that pentagon. If every interior angle is 108, and we know the interior-exterior relationship, what should that exterior angle be? Well, we know the relationship has to be 180. 60 plus 120 is 180. 90 plus 90 is 180. So 108 plus 72 maintains that 180 relationship. Now, think about how many exterior angles you have for that pentagon. If you extend each side, how many exterior angles do you have? 1, 2, 3, 4, 5. 5 angles, each 72 degrees. Do the multiplication, 360. We're going to do one more row together, and then I'm going to point out a couple of special unique polygons. You're going to complete this chart on your own. Next row, I'm seeing 6 sides here. Let's go with a hexagon. We know how many sides it has. Let's talk triangles formed. Pick a vertex. I'm going to go with A. And I'm going to draw in all of the possible diagonals that I can. A to C, A to D, A to E. I cannot draw any more diagonals, so I'm going to count the triangles that I have found. 1, 2, 3, 4. 4 triangles. Each triangle is 180, so I have a total of 720 degrees for an interior sum. If my hexagon is a regular hexagon, each of those 6 interior angles is the same. Let's divide 720 by 6. Every interior angle is 120 degrees. Think about the relationship between an interior and an exterior angle. We've maintained 180 in every row so far. Keep up that pattern. Each exterior angle of a regular hexagon is 60 degrees. Now, think about how many exterior angles you have in a hexagon. 60 times 6, exterior angle sum is 360. Looks like we've got time to do one more row to complete the front together. Let's talk about 7 sides. Not very common. Think about a possible name there. Anybody come up with septagon? Sorry, you're very close. I would change one letter. Hepta. H-E-P-T-A. Heptagon. That'll give you those 7 sides. Pick a vertex. I'm going to pick vertex A. Okay, be consistent. Draw in as many diagonals as you can. I've drawn in 4 diagonals. Count your triangles. I've got 1 up top, 2, 3, 4, 5 triangles. If every triangle adds up to 180, that's 180 times 5. So we end up with 900 degrees for our interior sum. If each one of those 7 interior angles is congruent, well, let's take 900 divided by 7. And we do end up with a decimal here. We're going to round to the tenths. 128.6. Any decimal that you have on this worksheet, please round to the tenths, 1 decimal place. Interior to exterior. You know that 180 relationship, that linear pair. Let's take 180 minus 128.6, and we end up with 51.4. If there are 7 interior angles in that heptagon, there are 7 exterior angles. The numbers will always match. It's a very direct relationship. Let's take that exterior angle times 7, and we end up with 360. So just from this front side, let's analyze the patterns that we found. We added 1 additional side with each row, and you'll notice that the number of triangles formed also increased by 1 as you progress down the column. Now, is there a relationship between the number of sides and the number of triangles formed? What are you seeing each time here? 5 to 3, 6 to 4, 7 to 5. We are subtracting by 2 to find that number of triangles formed every time. So on the back side, when you get to those 10-sided shapes and 11-sided shapes, you know how many triangles are going to be formed based on the pattern established here. Then, think about how you determined interior sum. We took the number of triangles formed, knowing what each one of those triangles had to add up to, and multiplied 180 by the triangles formed. That's what gave us our interior sum. And you're going to come up with a formula on the back side in just a moment that you can use for any polygon. Next, how did we determine the measure of 1 interior angle for a regular polygon? Well, we had to know, what does regular polygon mean? Okay, we know it means our 2 e's, equilateral, equiangular, all sides congruent, all angles congruent. Take your sum, divide by the number of sides, and you'll end up with your interior angle. Sum divided by sides, interior angle. Sum divided by sides, interior angle. And I showed my work each time so that when I look back at this paper, I can remember exactly what I did to find that value. I encourage you to do the same. From this column, we skipped over the exterior sum column, and there was a reason for that, because we haven't really talked about exterior sum up to this point. But we have talked about the relationship between an interior and an exterior angle. Take a look down here. Interior, exterior, interior, exterior, and again, interior, exterior. Okay? We have to maintain that supplementary relationship, subtracting from 180. So that's how we came up with each exterior angle measure. From this column, we then pushed back into the exterior sum. If 3 angles are each 120, 360. If 4 angles are each 90, 360. If 5 angles are each 72, 360. Notice what's happening, the pattern that's established there for exterior sum. That's going to continue over to the back side. All right. Last but not least, if you have any questions about the front side of this chart, jot it down on the bottom. Let me know. I want to talk about it on Tuesday. This is the first thing we're going to look at on Tuesday. Now, go ahead and flip it over to the back side. You guys, as a first task in class, are going to be completing the back side. I will tell you that drawing these 4 shapes, I'm going to leave that as a challenge. This is optional. Because at this point, you should be able to determine all of the values that you need to figure out based on the patterns established on the front. Continue them onto the back. Okay? This bottom row is going to contain some formulas that are key to this week. And I want to see if you can come up with those formulas before we talk about them together tomorrow. Okay, so your job is to complete the back side of the chart. Be ready for tomorrow's class. Some reminders. Your dictionary is due tomorrow. 6 terms, pictures only, no notation. You're going to complete the second worksheet from the sub for tomorrow's class. So if you get a chance to start it in here, great. If you don't, that means it's homework tonight. There is nothing that you are going to turn into the sub, and I know that you're going to be on your best behavior for the rest of the period. I expect that of my students. All right, again, questions, write them down for me. Here are your reminders. Good luck.